Bismillahirrahmanirrahim. In today's lecture, we are solving problem 4.2 from Applied Thermodynamics by McConkey. So problem is steam at 0.05 bar. So first I write given data. Steam at 0.05 bar. It means that pressure is equal to 0.05 bar and temperature is 100 degrees centigrade. Initially pressure is 0.05 bar and temperature is 100 degrees centigrade is to be condensed completely by a reversible constant pressure process. Process is reversible constant pressure process or isobaric process. Reversible isobaric. And calculate the heat rejected. Required is heat rejected. To find heat rejected, change of specific entropy point is 2 minus S1. Sketch the process on TS diagram and shade in the area which represents the heat flow. First we draw TS diagram. TS temperature in degree centigrade, S is entropy and kilojoule per kilogram per Kelvin. This is the curve, saturation curve. This is saturated liquid line, saturated liquid line. This is saturated vapor line or saturated vapor curve. This is wet region and this is superheated region. Superheated region. Now pressure is constant. It means that pressure is constant means that P1 is equal to P2 is equal to P is equal to 0.05 bar. And on TS diagram, constant pressure process line is such like this. Pressure is 0.05 bar on this line. Initially temperature is 100 degrees centigrade and pressure is 0.05 bar. First I check saturation temperature and pressure is equal to 0.05 bar. So from saturated steam table at pressure is equal to 0.05 bar. Saturation temperature is equal to 32.9 degrees centigrade and temperature given to us is 100 degrees centigrade. More than this value, it means that temperature from this point, this is saturation temperature. Saturation temperature is 32.9 degrees centigrade, but temperature given to us is 100 degrees centigrade, more than this value. It means that behind this point, that I take this point as T1 is equal to 100 degrees centigrade, because in this region saturation temperature is 32.9 degrees centigrade. So as T1, which is given to us as 100 degrees centigrade, is greater than Ts, so point 1 are properties. So properties of point 1 will be in superheated region, or point 1 will be in superheated region, or T1 is equal to 100 degrees centigrade as a in superheated region. So this is point 1. And Now second one, so if we read the statement again, here is initially steam is 0.05 bar and temperature is 100. Now the steam is condensed completely. Com Completely, this is saturated liquid line. After condensed completely, second point will be here, because at this point the at this point the liquid the steam is completely in liquid form after condensation. Condensation means that we convert the steam into liquid. So at point 2 on this line the steam is completely converted to liquid. Here this is superheated region. Here the working fluid is steam. Here the working fluid is wet region. Wet region means steam plus liquid, steam plus liquid. But uh, when reached to this point, it convert completely to liquid, completely condensed. So point 1 is this, point 2 is this. So this is point 1, this is point 2, and now shade this region, shade this region. So this is TS diagram and this is shaded region. Now we have to find Q, heat rejected, which is equal to H2 minus H1, and change in entropy S2 minus S1. So for this we find H1 and S1. So for point 1 is in superheated region. So we will find H1 and S1 from superheated steam table. So from superheated steam table, at pressure is equal to 0.05 bar and temperature is equal to 100 degree centigrade. H1 is equal to 2688 kilojoule per kg and S1 is equal to 8.768 kilojoule per kilogram per Kelvin. And now we find H2 and S2. So H2 and S2 are saturated liquid line here. So at this point H2 is equal to HF and S2 is equal to SF. So from saturated steam table, at pressure is equal to 0.05 bar, H2 is equal to 1, H2 is equal to HF is equal to 128 kilojoule per kg, 128 kilojoule per kg, and S1 is equal to SF is equal to 0.476 kilojoule per kilogram per Kelvin. So we can find Q is equal to H2 minus H1. The value of H2 is 128 kilojoule per kg minus H1 is 2688 kilojoule per kg. So Q is equal to minus 2550 kilojoule per kg. Negative sign mean that heat rejected is equal to 2550 kilojoule per kg, and S2 minus S1 is equal to S2 is equal to 0.476 kilojoule per kilogram per Kelvin minus S1 is equal to 8.768 kilojoule per kilogram per Kelvin. So S2 minus S1 is equal to minus 8.292 kilojoule per kilogram per Kelvin. Negative sign means that decrease in entropy is equal to 8.292 kilojoule per kilogram per kilo. And hence problem 4.2 is completed. And for more videos, please like and subscribe my YouTube channel and share with your friends. Thank you.